Hey, kids, are you ready?
Yeah, I wrote down. I'm ready.
If it's in standard form, there is a way you can find the vertex by just using A, B, and C, and it's actually derived from the quadratic formula, but I'm not going to bore you with that. I'm just going to give you the formula, okay? Ready? It's going to be kind of ugly. If you don't put it in vertex form, you can tell the vertex by just taking negative b over 2a, and then the y value is when you plug that in. So that's what f of negative b over 2a means. That means like take the x value and plug it in for the y value. And that'll be your vertex every time. And then you don't have to complete the square.
That looks like definitely a smart quadratic.
So the axis of symmetry is still x equals whatever the x coordinate of the vertex is, which is negative b over 2a. And you can still tell whether it opens up or down by looking at A. I don't even know if you need to write this down at this point, but oh look, I left a blank to fill in. If A is greater than 0, then your graph is going to open up, and it's going to look like this. So we say that the vertex is a minimum. That means f of that. That means plugging in that point. We'll do one in a minute together. And if A is less than 0, then your graph is going to open down, and so we say that the vertex is a maximum. And we'll talk more about maximum and minimums tomorrow. I say tomorrow in Spanish. Mañana.
It's morning.
No.
Well, it's morning and tomorrow.
Because in English we don't have any words that mean more than one thing, right?
Yeah, but what if you stop saying?
I know, mañana.
Somehow.
Mañana.
That would be funny. Meaning mañana. Whatever. And then I don't know if I haven't hung out in the morning time because I get out
You can also graph these. If you know the vertex, the x and y intercepts are also other things that we look at. How do you find a y-intercept of any equation? Yeah, well, how did you get c as the y-intercept? Yeah, y-intercept is when x is 0. So if you plug in x for 0 on a quadratic in standard form, the y-intercept will always just be what c is. So it's like a free point. The x-intercepts are when you solve that equation. So I'm just going to put the x-intercepts are the solutions to the equation. Which means sometimes they're going to be ugly and we might not care about them. Sometimes they could be imaginary, but sometimes they work out kind of nice. So x-intercepts are sometimes useful. Equation, it's notes. You should never write out full things in notes.
I know.
Why wouldn't you just make an equal sign for EQ? I mean for equals.
If I put EQ, I wouldn't know what it means.
Oh my gosh, you guys are crazy.
Equation.
EQ is equation, solution, shorten it up.
Why did you shorten up solution?
I do, but I didn't on that one.
Put
Huh?
so.
All right. The bad part is the homework has like a million directions on it, and I want you to see the same directions. You don't have to write it out word for word, but just know they want you to find a lot of stuff, okay? Oh my gosh. So it says graph each function by determining if it opens up or down, finding its vertex, axis of symmetry, y-intercept, and x-intercepts. If you want, you could just put graph each function, and then we'll list all that stuff out. Determine the domain and range, and determine, Nathan, it's your favorite stuff, where the function is increasing and decreasing.
I know that. You just screwed over every time because I write it.
It's not wrong, it's just wrong. So I'm going to do a double page here. If you don't want to write all this down and you want to just do the problem, I'm okay with that. These are exactly how the homework directions are today. The good news is you don't have to do that many problems. You're doing so much stuff, right?
The way you just walked forward, I look
I don't know why I'm putting my arms up like this, but to do what? I do this thing on my Wii game at home, and it makes me do jump squats. Jump squats are my worst exercise in the world, especially after you do lunges for like 8 times, and then they're like jump squats, and I just want to die.
Honestly, I don't know what a jump squat is.
You jump. Or you jump forward.
There's somebody gonna walk by right now. That'd be so funny if this fucking walked in.
What do you think?
That thing that girls go to like keep their body in shape. I'm into it.
What?
It's like there's like 30-year-old women
Provide it.
there.
Instead of doing like a song, you need to do a math.
Workout video.
Why were you
All right, does this open up or down?
down?
This is negative, so we can say that it opens down. Find the vertex. This is the formula thing. The vertex is going to be negative b over 2a, and then whatever we get for that, we're going to plug in to find the y value. So it looks kind of awful, but it's really just plugging numbers in. What is b in this problem? So that would be negative 6 over 2 times a. What's a in this problem? Ooh, I'm like breathing hard now. That's how out of shape I am.
Good question.
So negative 6 over negative 6? Is this about math or about my workout?
It's about that.
Okay, what?
Are you gonna have probably another example? We have to do this way or can we cheat?
I don't know. I haven't decided yet. But you should, this way isn't bad. It's just plugging it in.
Yeah, but I like the other way better. It's a lot more
Okay.
complicated.
I don't know. I'll probably let you choose. But do you agree that this is just 1?
Negative.
Nope.
I put it at 3. I didn't see negative.
If x is 1, can I plug 1 into this problem to figure out what the y value is that goes with that vertex? Yeah, that's what this means. F of negative b over 2a means now plug 1 in and tell me what you get, and that's your vertex. Do you have to show all this work every time? No. I just want to show you where it comes from. So if I plug 1 in here, I'm going to get negative 3 plus 6 plus 1. You with me on that? Because that's all just 1. Which means my vertex is 7 minus 3, 4. If you, yeah, you could complete the square to do it too, but I'm just showing you this way. Yes. So the formula gives you the first part, and then it just says, hey, plug that in to find your y value, because it's the x value. It also wants you to find the axis of symmetry. The axis of symmetry is still just x equals whatever that first part is, so that one's not bad. What would my y-intercept be on this? Remember that your y-intercept is when x is 0, so it's always going to just be c. So in this case, my y-intercept is 1. The x-intercepts, I don't know how much I'm going to push you to solve these out. If this is not factorable, I think what's the point of doing the x-intercepts, because they're just going to be ugly. So the book says find the x-intercepts if any. I think I'm going to amend that and say find the x-intercepts if they're nice. Because I don't care if they're ugly. But we could like do the quadratic formula, we could do all this stuff, but looking at this, if I was going to factor this, I would multiply the first and the last together, and I would say, is there anything that multiplies to give me negative 3 that adds to give me 6? There's nothing, which means that's not going to be a pretty number. It's either going to be imaginary or it's just going to be an ugly decimal. And so I'm just going to say that there are no rational x-intercepts. No rational, I'm going to say rat for you there, x-intercepts. And I'm okay with that. If you want to get the decimal, you can, but I'm not going to. No rat. Now before we do B and C, we should be able to use this information to make a decent graph. And then from the graph, you should be able to answer B and C. This is where probably I'm more of a fan of vertex form as well, but I want to show you this because it is in your book. And if you do vertex form, you're going to be able to make a decent graph and answer these questions as well. The only thing that vertex form is not easy to tell the y-intercept. Like, you actually just have to plug 0 in for x and solve it. So if you do that on your homework, I'm not going to mark it wrong. Except for Nathan's. He's the only one that I would mark it wrong on. So if I graph my vertex at 1, 4, if it helps, you can put in the axis symmetry. I don't usually do that in this high-level math class that we're in. But remember that the axis of symmetry cuts that graph in half, so half of your graph should be on either side. What's the other point that we know on this? We know the y-intercept is 1. The great thing about a parabola is if you know one point on one side of the parabola, you get a free point on the other side, right? Because it's the same on both sides. So if it's right here, do you agree I can flip it over and say there's another point right there? Does that go with the idea that it should be opening down? Yeah. And so I think that, to me, that's pretty good, roughly speaking. If we would have found our x-intercepts and found those decimals, you know, we would have had those other points there, but I'm okay with that. Yep. What would the domain of this be? Domain of a quadratic function. Any quadratic function. X's can be anything, because although it's kind of opening down, it's still going to go on forever, and every x value that you could think of, you could plug in there. So the domain of every quadratic formula is all real numbers, which I'm going to say is negative infinity to infinity. Is the range of a quadratic formula ever going to be all real numbers? Nope. It's a starting or stopping point every time, that vertex. When it opens down, do you agree that it's always going to go to negative infinity? And when it opens up, it's always going to go to infinity? And then you just have to figure out where it starts or stops. So the range on this one is going to go down to negative infinity because it goes down forever. And where does it stop at? The y value. Is 4 included? Yes. Yes. Or you could say, if you don't like this way, remember you can say like y is less than or equal to 4. That would be in set notation. Could you have found all that stuff out by completing the square and doing that? Yes. And so I'm not opposed if you hate this way. You don't have to find the vertex this way. I just want to show you that you could find the vertex this way. No, that's what I'm saying. I don't think it's terrible, but you know. I have some more of the same stuff, but I think I'm just going to give you some homework and see how we do on it. Oh yeah, we didn't do C.
Isn't that the part where
That's the important part that people miss a lot.
not the same thing?
If you have a parabola, will it always be both increasing and decreasing, like half the graph's increasing and half the graph's decreasing? Like, won't it always be it's increasing for so much and then decreasing for so much? Oh my gosh, please erase. Ready, go.
You're going off the thing.
If you have a parabola like this, do you agree if it's opening up, it's going to decrease to the vertex and then it's going to change to increasing? And if it's going down, it's always going to start by increasing and going back down. So the changing point is always going to be the vertex. Do you agree with me on that? So if you know the vertex, you could tell me where it's increasing and decreasing without actually even graphing it, because you know the vertex and you should know whether it opens up or down. But you have the graph, so just look at it.
Teacher, pardon the interruption here.
So this one is
We had our
increasing
drawing for yesterday's
from
middle
negative
school
infinity
incentive party.
up
We
to
drew
the
a
vertex,
sixth grade
which is the
winner, a
x
seventh grade
value.
winner, an eighth grade winner. The following students.
Increasing,
rated
decreasing
or
are always
voted
x values.
If you would, during your passing period.
And then it's
the bell rings,
decreasing
please
starting
come
at
to
that
the main
point
office and see Miss Newman,
and
she'll
going
get your
down.
order
So
for
just
you.
know that on a quadratic,
Our
increasing and
sixth grade
decreasing,
winner was
it's always
Hannah
half and half,
Pacelli.
wherever the vertex is.
Our seventh
Okay.
grade winner, Andrew Carr.
We need like separate intercoms for junior high and high school.
If we could get,
I'm over
Tanner,
this.
Brittany, and Andrew, when the bell rings, please come up to the main office. Miss Newman will meet you out front, and we'll get your order for your pizza for tomorrow. Thank you, have a good day.
Man, I was really hoping there. Like, my heart was like, oh, so what? I was so excited.
Okay. It's all about the x values. When you're talking about increasing and decreasing, we're talking about x values, not y values. So when I say it's increasing from negative infinity to 1, I'm talking about these x values. So this is negative infinity, and then it's decreasing from 1 all the way to infinity. So it doesn't matter that it's pointing down, because I'm talking about the x values. Okay? And so increasing and decreasing should always go from negative infinity to positive infinity, and you just have to break it up from where it changes. Okay? Good question. We're gonna have like, well, just one more. I think that's only 4 problems, right? 33, 36, 39, 42.